Hello, everybody, and thank you for coming to our Fridays with Daren, our live stream. Today, we have two very special guests here in the Miami sustainability community. We have Gray Reed and Phil Stoddard, obviously, along with Daren Golden and myself. My name is Dane. Thank you for coming to check this out. Today's project is something that you may not have seen before, and it offers a historical perspective on climate change, which is something that's oftentimes difficult to try to wrap our heads around given that even just the present day perspective on climate change can be confusing. So first, let me introduce our guests, and then I'll talk a little bit more of an introduction about exactly what they've made, and then Gray will be showing us in detail what's going on. So first, Gray Reed here. Gray Reed is a professor, and she's been working in education. She's in the Department of Architecture at the College of Communication, Architecture, and the Arts at Florida International University. Along with her on the panel today is Mr. Phil Stoddard. He's the former mayor of South Miami and a professor of biological sciences at FIU. His lab asks the question, how do communication systems evolve and how do they function? But his current project is understanding how mosquitoes evolve to evade our control and what to do about it. I think everybody can relate to the importance of controlling mosquitoes. So today, to get into Climate by 10, which is the name of the project, I'm going to let Gray talk about it, obviously in detail. But this, here, I'm going to screen share here on my side. Let's see here. This is what we're looking at today. And we can realize some things, I think, about ourselves as humans from understanding how we've related to our environment for potentially, much longer than we would have ever imagined that we could see how we related to our environment. And so Gray's going to talk about how we have changed over the long term, and then also look into the future and see what that looks like as well, depending on how we decide to behave and what we optimize for. So Daren is also with us today. Daren Golden is the CEO of Golden Solar here, a very incredible local solar installer, local to Florida. So anyone in South Florida and Central Florida who is looking to contribute to a more successful future based on Gray's predictions of what could happen, one of the great ways to do that is by switching your energy source to renewable energy. Daren's going to provide some questions for Gray and Phil, or for Gray, and also be able to maybe provide some expertise from his area. So without further ado, I'm going to turn the conversation over to Gray, and so thankful to have you and very interested to hear some of your insights and some of your research. So thank you, Gray.
Okay, thank you. So can you stop? Yep, okay. Now, can you see me, or do I need to share my screen or do something different? Okay, very good. Well, thanks for coming. I really appreciate it. I'm Gray Reed, as I've said, professor of architecture at FIU, and what I have to offer is a voyage through time where we walk back in time by powers of 10 to see where we were in terms of climate. So my hypothesis is that at every time scale, 10 years, 100 years, 1,000 years, 10,000 years, we see our own situation a little bit differently. So I'll share my screen at this point. And there, you should be seeing the title. So this is the title page, right? So this is a web book that I've been working on for about the past 3 years, really doing a series of research projects on what is known about where the climate was in the past and what is projected for the climate in the future. And I find that when I line all these things up, that you get this kind of zoom perspective that allows us to understand our own situation a little bit better. This is all available at Climate by 10, climatex10.net. You can fuss around with it yourself. If you go on the web, you can walk back, you can look at the graphs. Here, I'll start actually at the end of the presentation, and this is for Daren. This is a solar community in Germany where they really take this stuff seriously. And this community generates a good bit more power than they use, even in sort of low light Germany. So I think there's a tremendous future for us there. So I'll start in the present. And the issue really is that we can't see carbon dioxide. So we don't see the damage being done, that our sources of energy are often invisible to, and unless you live on top of an oil refinery, you really don't see where the energy comes from. And we often don't see how the energy is used. And this picture shows the electromagnetic waves that are emitted by cell phones and cell phone towers and so forth. So really the point is that both the source of energy, the use of energy, and the use of energy are really invisible to us. So it's hard for us to wrap our head around the issue. However, the effects of climate change are making themselves felt everywhere. Just outrageous weather, torrential rain, drought, that in this map we can see over the past 30 years the changes in the patterns of rainfall and drought. And we can see in particular, you can see my little cursor there, that in Central America, there's been a heck of a drought. And that is what has been sending climate refugees north into Texas and into South Florida. So we see the effects. There is increased rain around the Mississippi Valley, which is continuing to be a problem. And we hear about flooding even in the news in the last, right up in here in Michigan, tremendous flooding that is going on right now. So these effects we do see. And what we also need to see is the potential. That here's a map showing areas that can be, where the solar energy can be harnessed quite easily, and areas where wind energy up in the north there can be, are available for us. That little square in the middle, that is the area of solar panels that is necessary to power our planet, the level of energy that we're using right now. So we're in between this consequences of climate change and the potential for us to do something about it. And the only question is, you know, what are we waiting for? So where are we? I've used 4 indexes: population, CO2 concentration, temperature, and sea level. So the population now, close to 8 billion people. That's a lot. Atmospheric concentration up over 400 parts per million, and this will become more meaningful as we move back in time. Temperature, this is average global temperature, almost 15 degrees Celsius. And sea level, I'm measuring sea level using the sea level in 1900 as a datum. So watch those numbers. Those numbers will remain with those spots on them so that you can track them as they change. Okay, moving back 10 years, we can see, all right, there the population is starting to go up. You can see a change. You can see the up and down in the CO2 concentration over the year, and you can see it kind of edge up over that 400 mark. Global temperature goes on pretty steady, goes up a little bit at the end. And sea level also has been dead steady, and then there's a little tick up at the very end.
Not quite dead steady, you just can't see the change.
Right, well, pretty dead steady. Okay, so at the scale of decades, tens of years, what happens? What kind of decisions do we make? Really, I'm an architect. These are architectural decisions. Architects and planners think in terms of decades. We're planning ahead that far. And what that means for us is that we need to be planning, we should be planning now for what's going to happen in 10 years, 20 years. They tell us that we've got 30 years, 20, 30 years before the situation is out of control. I'm not sure if I believe that, but never mind. That means that, and so, you know, you think, hey, well, 30 years, boy, that's a long time, you know. No, it isn't. That the planning needs to happen at the scale of decades.
So when you
So
say
that-
you don't quite believe it, do you mean you think that we're fine, or do you think we're toast?
No, I think we're in deep doo-doo.
So not
Okay.
30 years, less than 30 years.
Less than 30 years,
Ah,
and
okay.
particularly when you take the planning horizon into account.
And by the
Okay.
planning horizon, you mean the time that it takes us to organize action, that
Yes.
there's lag time in implementation?
Absolutely. That planners, particularly infrastructural planning, you know, they're projecting decades into the future. You know, think how long it takes to plan a highway.
It takes congressional authorization of the funding and all that kind of stuff. It's not quick.
Yeah, yeah. So that the point here is to be thinking in terms of decades, and that is the scale at which infrastructural change happens. And so that's, you know, that's kind of where we are. So here's a map showing that kind of change over decades as it has continuing to affect our resources. So you can see the what is left of our intact forests, depleted soil, and compromised habitat, also highways. So it gives you a little snapshot of how our actions over decades have changed the landscape. Okay, here we are at 10 years ago. Now we're going to zoom back to 100 years ago. All right. Zoop. Bang. Same numbers.
This sounds very important for this, by the way.
Yes. So
that was a
numbers.
very nice transition. That really puts it in perspective.
So if you get on the website and you're just finding the experiences in the same, call Gray up on the phone and she'll make the sounds for you.
Okay, well, there are your dots. So now you can see the same dots in the perspective of 100 years. Whoa, look at the population has gone up from almost 2 billion to almost 8 billion. That's like 4 times. That's outrageous. And you can see the CO2 go up about 100 parts per million. That's a lot. So you can really see the change and see the swing. Sea level's been
that CO2 rise, by the way, it's risen by a third.
Yeah, which is a lot.
Okay, it's risen by a third. 35%, somewhere in there. Go back to sea level rise again.
I'm going the wrong way. 10 years ago. Okay,
all right. So when we were saying not much was happening, you start to see it here. That's 22 centimeters for those who think in the Old English system there, that's 8 inches. 8 inches of sea level rise is what's causing now the Keys to be flooded for a month at a time and flooding along our coasts. And we've got parts of, Norfolk, Virginia, Hampton Roads. Those guys are really in serious trouble. The U.S. Navy's been pouring money in there, which is the only reason they're still functional. Miami Beach has spent $500 million and they're just scratching the surface. 8 inches is significant.
Right, but you ain't seen nothing yet. Okay, so where were we 100 years ago? 100 years ago was really when we shifted in a big way to fossil fuel as a power source. And this is when our source of energy became invisible. And it is when the sort of modern world opened up. To have this ready source of power meant that people and animals didn't have to do all the work, which was just amazing, which meant that we could do things that were unimaginable before. We could travel, we could go places, and we could do things, the manufacturing, and produce stuff at a scale and a level that was just unimaginable before. So that's the big change.
And also people's bodies didn't wear out so fast.
No.
Because a lot of this work was manual, and the life expectancy, people died in their 40s and 50s, and that was expected. This changed it.
The other thing that happened was electric lights, and the street lighting in particular, which meant that you could go out at night. and that you didn't see the stars anymore. So we're shifting kind of away from that sense that had always been of the celestial universe and where we were within it. The other thing that's funny that this picture shows is the pollution, particularly from coal, that put particulate matter in the air, and so the electric lights would then reflect off of that smog essentially in the air and would turn the sky like amazing colors. I remember this from Philadelphia, that you would look up and you say, what color really is that anyway? I don't know. And here is the population, forests. You can see the difference from the previous map of how much more forest there is. And even here in 1900, deforestation was a tremendous problem already. But you can see the population concentrations. The brown is also the coal deposits. So here we are at 100 years ago. We're going to zoom back again. Ready? Zoop. 1,000 years ago. Now we start to see the real rise. Now we start beginning to understand that this population CO2 is not a simple blip in the system, that this is a real change from what had been a steady state. So where were we 1,000 years ago? We were in that really the Islamic world was the center of the academic universe, and they were inventing machines. They had revived ancient knowledge, which was 1,000 years before that. And they were creating essentially toys that could run on their own. They were fascinated with automata, little creatures that, like, what wind-up toys that can move on their own. And that was the beginning of sort of harnessing a power that you couldn't see. So it had not yet been put to practical use, but the inventiveness was there, this sort of explosion in devices. Okay, the world, where were we? That's the population. Each of the dots is 1 million people. And you can see the land under cultivation. This is how we are transforming the earth. So 1,000 years ago, we're going to zoom back again. Zoop. Boom, 10,000 years ago. Now, this is a little bit the oh shit graph. This is the one where you really see that over 1,000 years that the CO2 has been pretty steady, and then bang, we go up quite a lot. Likewise, I mean, population is just unbelievable. This is at that scale. And sea level, here you see the dip in sea level, which was the beginning of which was the end of the ice age.
It's actually not a dip. Can you go back one?
Mm-hmm.
Yeah, so it's not a dip in sea level. It's a
rise
in sea level
from the previous condition.
But here's what's really interesting. Look at this here. So if we just go back 7,000 years, 6,000, 7,000 years, which is about the history of our civilization, recorded history of civilization, maybe it's 5,000 years. The sea level's been flat. The sea level has stayed still for all of recorded history.
Yes, all of civilization.
So mankind, we believe that the sea level doesn't change because that's everything we've known as a civilization. But this graph, you move to the left and you see the sea level drops precipitously at the end. So before we were recording history, there was stuff happening.
Yep. So here we've got all of civilization. We got Egypt, we got Stonehenge, we got the classical age of Greece. All of civilization is in this kind of snapshot. All right. And where were we? This is one of the earliest, well, it is the earliest temple that was ever built, about 10,000 BC, before agriculture was invented, before animals were brought into domestication. What it meant was that people had to organize themselves. They had to share a common belief before any of that stuff was possible. So hunting and gathering tribes came together, and they essentially built a civilization at a larger scale. And from that, we're able to invent agriculture that then transformed the earth, transformed the ground on which we're walking. Okay, at the same time, the domesticated animals, but just previous to that, at the end of the last ice age, there was a mass extinction of large mammals, mostly mammals, although some birds in there too. But essentially, people ate everything, shot, killed, and ate everything that they could. And that extinction around 14,000 years ago is pretty remarkable. And there is some debate among scientists whether it was climate change or hunting, some combination of the both. But that is our relationship with the animal world, either eat it or domesticate it, or both. So here we are, 10,000 years ago. We're going to go back again. Here we see the entire ice age. We see the dip in CO2 from here where we are and we go down to about 100 points in CO2 level. We see the temperature go down to a low of 8 degrees Celsius. That's really cold, by the way, really, really cold.
That's the average temperature across the surface of the planet.
Across the planet. The tropics stayed a lot more steady than the poles did. So the further north you went, the more dramatic the change was. And look at the sea level. I had to shift scales here, that we were at the scale of meters. Now we're at the scale of hundreds of meters, down 120 to 130 meters. Whoa, that means that all of the continental shelf was exposed as land.
Tell us something that's 130 meters high in Miami.
Oh, what it's going to be, the 130 meters high.
How many stories is that?
It's about 40.
40 stories?
40 stories, yeah. So like
So
the
this is like
Bank of America building?
This is like the buildings on Brickell.
The buildings on Brickell, yeah.
So those things would just be either underwater or just peeking out of the water.
Yeah.
Whoa, okay.
Yeah, yeah. So this is a map showing the migration of people from...
Except back up a second. So no, they weren't underwater. So it was that much lower.
That much lower, yeah.
So they weren't
exactly.
they weren't inundated. They were...
No, it was that much lower, right?
So essentially, so then the whole continental shelf...
The whole continental shelf was exposed.
Sticking up, going down as far as one of those buildings.
So those buildings would be twice as high, because instead of relative to current sea level is that much lower.
They'd be up on a plateau, a high plateau. So Miami wouldn't have been,
Miami would be...
We're not coastal. We would have been like
way inland.
A couple hundred miles inland. Yeah.
Yeah. I mean, really, it's the whole continental shelf. And I mean, I think about archaeology. Imagine doing underwater, archaeology, underwater archaeology. There's a lot of stuff going on there in that in that land that was exposed and is no more.
So that meant that sort of all around the planet where people did live, they had moved out to the coastlines, way, way out.
Right.
And now, how long ago was this again?
This was 15,000 years ago.
15,000 years ago. Okay, so people were just coming into the new world at this time. And that meant that when, of course, everybody settled on the coast, because that's where all the food is. So people moved down the coasts of the Pacific coast of the U.S. and they made it around down into South America. So they would have been a coastal people living much farther out than they are today.
Right.
And so what that kind of tells us is that from there back in history, people had moved in and out with the coastlines as the sea level went up and down. So it wasn't a case of building your buildings out of concrete or stone or whatever. You traveled light and you always tracked the ocean as it moved.
Yeah. And here, this map shows those black areas. That is the continental shelf that is exposed by the lower sea level. So the Red Sea disappears entirely, and this area in Indonesia disappears. The distinction between Australia and Borneo is gone. And people traveled from our origins right in here in equatorial region out across the world. All right, so here we are. We're going to go back again. Whoops. There we go. Now we see ice ages come and go. You know, the ice age was a big deal for us, but it was only one out of a lot of them. And so we see the CO2 level go up and down, up and down, up and down, temperature boing, you know, up and down, up and down. I mean, I've become really interested in the Eemian period, which was the last interglacial.
So if we can look at this for a second, it looks like the ice age itself lasts a pretty long time.
Yes.
And then there's
the interglacial is short.
A brief warm period, and then boom, you're back to a long period of ice again, and a brief interglacial. Actually, this is a complicated one.
Yeah.
But then the same pattern. It's cold for quite a long time. You know, you take a brief tropical vacation, and bang, it's cold again.
Yep. And what you need to see here also in terms of sea level rise, that when the sea level is going down, it takes a lot longer than when it's going up.
It's like the reverse. So
yes.
so the sea level is high for a long period, and then it's low for a short period. And that's because it's taken so long.
Taken a long time to get down there.
But if you go up to the black one, I think you find out the reason why.
Yeah, well, this is
that's carbon dioxide.
Carbon dioxide, and they go down slowly, and then boink goes up really fast, and down slowly, and boink. And what our friend Hal Wanless said is that the oceans, you know, they make a beach where they meet the land. And when the sea level is going up, the oceans just leave that beach behind and head inland. And they don't establish another beach until they're ready.
Until they're stable.
Yeah, until they're stable.
So I got a quick question.
Sure.
It looks to me like we're not that far off of the highest temperature in recorded history, right? I mean, that last peak right there.
Right here.
Yep, that right there. That would be the highest temperature in recorded human history, right?
Well, it wasn't really recorded at that point. I mean, we only started
unrecorded history.
Yeah,
unrecorded history, right?
But yeah, and we weren't really around. We were in Africa, you know, back then, so we weren't.
So that's really, the average. That's the average for the.
Yeah, that's the average. You know, and all of this information comes from the ice cores.
But people have said recently that humans did not evolve for a hot planet.
Yeah, we're an ice age creature.
Yeah, and this really shows that we're a creature of the ice ages. We're not, our physiology is not evolved to deal with hot.
Yeah.
So this is a problem for us. We don't, and one of the things we've learned is that, like, even students don't perform well in schools when it's warm. Obviously, people can't perform well outside, but you don't think well, you don't learn well. This is a problem. But there's something really important I want to look at on this graph, and that is this gradual slope. This is really important, and we're going to come back to this a little bit later. But I want you just to note right now, look how slow it takes for the planet to drop the CO2 level from its high here to its low here. That's a period of about how long, Greg?
About 10,000 years. Is it?
No, it's about 100,000.
About 100,000. I'm sorry.
About 100,000 years.
That's powers of 10, right?
100,000 years, and we are, and that's to go from just below 3 to just below 2, and that's hundreds, right? So from about 300 to 200 took the planet about 100,000 years, and we're at above 4. So how long would it take us to get back to 3?
That's a question, isn't it?
About 100,000 years.
As a way to begin to think about it. Yes,
okay.
Of course, there are a lot of other factors, but
100,000 years it would take the planet just to get back where it was at the beginning of the last century. Okay, that's an important discovery, and this brings up something.
Yeah.
That we'll just talk about real quick, and that is that when you're flipping through this book, there's all kinds of questions you can ask, and there's all kinds of stories you can tell. So Gray's telling you one set of stories, but these graphs tell many, many stories.
Yeah. Okay. So at this point, 100,000 years ago, we were it was Homo erectus. We weren't yet sapiens, And we were just emerging from the forests out onto the plains of Africa, which were full of wildlife. This is the sort of golden age of mammals. And, you know, you can't imagine how many creatures our landscape can support if given half a chance.
By the way, this was their oh shit moment.
Who's
All these Thompson gazelles are looking at that guy and going,
oh shit. Okay, here we go back again. A million years. Yeah. Boing. This is 10 million years ago. And here was the last, we can see the last time that CO2 concentration was where it is now. About 5,000 years ago.
1,000?
I mean, million years ago. I'm sorry. Powers of 10. About 3, 4, 5 million years ago was the last time that CO2 concentration. Okay, where were we? So the temperature was 2, 3, 4 degrees warmer. We're trying to hold our temperature change now to 2 degrees. But here we are up at 415. Oof. Sea level.
So hang on. So this gets back to Daren's point. So he said we're about as warm as we ever were right now in the whole ice age cycle. So you're saying
seems like we're really close. Seems like we're not that far from that high point.
Exactly.
So you go back to that level of CO2, and you are warmer than we were at the peak of the last ice age cycle, which was the pretty extreme cycle.
Right. And sea level was 10 to 20 meters higher. We were up in North Florida a couple of weeks ago, and that would be the coastline essentially. So it was a different world back then. This is where we evolved in the forests of Africa, and there was a lot of intelligence in the forest. That the parrots were smart, and the elephants were smart, and all the primates were smart, and they were all competing with one another for the fruits of the forest. So really our intelligence comes out of that sort of soup of, of evolution. So if we go back from here, boom, there we are 100 million years ago. CO2 is just out of here. It is off the chart. Up, they have recordings of up like 1,500 parts per million. Temperature, oh my heavens, 27 degrees. You can't imagine how hot that is. That is just an oven.
That's 80 degrees Fahrenheit.
80, yeah, I mean,
that's just the average for the planet.
Right, average for the planet. I mean, 100 degrees centigrade will boil water, but so
this will melt asphalt.
Yeah, right. Okay, the sea level was up 120, 140 meters. That covers like the Midwest. It's a very different world. And it was a world that supported a different kind of animal life as well. That it was just at the evolutionary moment when plants and animals were co-evolving for pollination, that plants would make nectar so that an animal would come in flowers and drink the nectar and then take their pollen to another plant.
Yeah, so this is when flowers were invented.
Flowers were invented, flying was invented, that the sky was full. But we're not designed to live in that world. And this is what that world looked like.
This is before mammals.
Really before mammals. That, here's the entire Midwest flooded. Here's Europe. Here is the ocean that is opening up between South America and Africa. That Australia was still connected to Antarctica. And the green here are more or less the locations of what we currently are using as oil fields. And they really formed in these shallow oceans.
Can we go back to to your pterosaurs there? Yeah.
The pterosaurs.
So what, I'm a zoologist. One of the things I notice about this is that these are animals of hot places. I mean, all these reptiles are we call them cold-blooded, but really they're warm-blooded, and they depend on a warm world to keep their blood warm. So it wasn't until the dinosaurs came along that vertebrates figured out how to maintain body temperature. And then the mammals pop up, and of course we're really big on maintaining a constant body temperature. That's hard in a place that hot to do that.
Yeah.
It's a real challenge to maintain, to pick a body temperature and keep it when the temperatures are that high, and probably the temperature swings are
extreme.
pretty extreme.
So all right, we're going to go back one more time to 1 billion years ago. And here you see the extinctions that in this zone over here, this is when the Earth was just a snowball. There wasn't anything living here really at all. The Cambrian explosion, that's when plants were invented, algae in particular. Here you've got extinction, 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 extinction. Here's the most recent KT extinction, and they say that now we are moving through the 6th great extinction. So that puts that in perspective, and this is what the world looked like 1 billion years ago. And in that world,
hey, this is really interesting, you know, because so there's no land to speak of up near the North Pole. Right now we've got Greenland up there, which is able to hold a huge amount of ice. Back then, there was nothing up there to hold ice. So what was the significance of that?
Well, there was no ice. I mean,
nor could there be any.
Right, but the formation of the ice is one of the things that took us into that cycle of ice ages.
But you have to have land up on the pole in order to even support the ice. And the other thing that's really important here is that a lot of our temperatures are regulated now by ocean conveyors like the Gulf Stream, and you can't have conveyors in a world that looks like this.
So that world was a world where the CO2 level was incredibly high, and the oceans were like a soup of algae. And the algae were the little plants that would absorb that carbon dioxide into their bodies. Their bodies were made of carbon, and they would release oxygen. So over hundreds of millions of years, they changed the atmosphere. And when they died, their little carbon bodies drifted down in the ocean, and they formed huge carbon deposits, which were then pressed into coal and into oil. And it's those deposits that we are now digging up and are releasing back into the atmosphere. This is climate change acting at the scale of hundreds of millions of years. I'm going to let that sink in for a minute.
So can I ask a question? Can you go back to your time graph? Can you show us over what period of time all of that carbon got pulled out of the atmosphere and shoved into the ground?
Well,
what period are we looking at here?
If you listen to the news and they talk about various oil deposits, they call them like the Permian Basin.
In Texas, sure.
In Texas, there it is. So it's all of, yes, the Permian. So it's all of this time. And that's the thing, it's the scale.
So let me look at this a sec. So about 500 million years ago, the process began, and it was still kind of going on, and you can see the CO2 come plummeting down here around the Cretaceous period. So a period of about 400 million years it took to get all that CO2 into the ground.
Exactly.
400 million years it took to sequester this stuff, and 100 years to put it back in to the atmosphere.
Yeah, let that sink in for a minute.
In 100 years, we've undone 400 million years of carbon sequestration.
Right.
Whoa.
And that's the scale at which these things are happening. All right. What about the future?
Hang on.
Oh my God.
Before we get to the future, I'm just still dealing with the past here. I mean, this is like profound, horrifying stuff, Gray.
I get that.
And this is one of the things that I get out of your book. I got to say, by the way, also for folks who can't tell, there's also a book that goes along with this website. It's the same, But we spend a lot of time sitting up in the evening, flipping through the pages of the book and just staring at the stuff and trying to make sense of the planet. But I mean, the past, there's the big past and then there's the recent past. And this is really disturbing stuff.
Yeah.
Okay, now you can go to the future.
Okay.
But
Okay.
I'm still coping with the past.
Yeah, I mean, this is why I did the book, in order to put all of this into perspective so that you could see it visually. All right, what about the future? Well, we're going to lose a lot of cities. We're going to lose cities to too much heat. This is Dubai. And we're going to lose cities to too much water, like Miami, or too little water, like Cape Town, South Africa, and probably maybe Los Angeles. Here are the projections by the IPCC, which is the governing, the body that has been pulling together information. This is thousands of scientists across the globe that are coordinating to create these projections. And of course, I've just shown 3 out of a possible 6 or 7 different possibilities. So this is uncontrolled growth in population median, and this is more modest. This is uncontrolled growth in CO2 up to 1450. I mean, you just can't imagine. This is probably the more likely scenario, where we level off at about 600, which is also pretty unimaginable. And this is if we really get things under control and start to bring it back down again. And this curve would involve some kind of carbon capture technology that we don't really have. Temperature, again, up to 20 degrees. Whew, that's hot. Here, maybe a little lower and a little lower, and sea level rise could choink, up. And the important thing about this is that it's not stopping. This is not like the top. It's just getting going. So my question is, if we know where we came from, can we imagine another way to live? And there are a few things that I like to look at, and that is an idea of managing habitat. And now they do this in the national parks. They watch, what are the populations of various animals, and they'll control, predator populations, or they will essentially farm in order to create grasslands that are rich and healthy. They say that in order to grow cows, you need to grow grass. So can we manage the habitat to support a diversity of wildlife? And can we give back? And this is a proposal, half of the land and half of the ocean to natural processes. The argument is that if we do that we will have plenty to eat, that they've already set aside some reserves, and there's a proposal now to expand the underwater Biscayne Bay wildlife refuge.
Make a marine protected area.
A marine protected area that's much larger. And of course, the sport fishermen are fighting it. I think the commercial fishermen are not fighting it as much as the sport fishermen are. And can we integrate gardens into our cities? Can we make productive fruit and vegetable gardens that are part of our lives? And here's another little vision of robotic gardeners. There's a lot of work in permaculture that has to be done by hand, that our agriculture has really been designed for the tractor, for the machine that can move through the rows. What if we had really smart robots that could do all of that detailed work and let us grow more complex gardens that support themselves? Rooftops are sort of our salvation. In the cities, we can make parks, we can make forests on top of parking garages. We can have sports up there that we can integrate that land into life in the city. And here we are back again at our solar panels. So the suburbs can be really just blanketed with solar panels. They can make a lot more power than they need, and that can be a major part of our power generation. And this is a power source that you can see. So this is the point, that it's got to be integrated into the way that we design and the way that we live our lives. So the final question is, what can each of us do with our various talents? You know, whether you're a poet or an architect or, you know, play sports, whatever, what can we do with our talents, each of us, to help address the crisis of climate change? And that's where I'll leave it.
That was a lot to take in. I think, as Phil said, just trying to wrap our heads around the past is enough. I mean, obviously, one of the first things that comes to mind is that we need to be optimizing for our future, given the fragility of our present. One of the things that you talked about, and we've talked about this before too, was something that I think this reveals about human nature, which was even pre-industrialization, our relationship with other animal life on the planet. You mentioned that there were extinctions in animal populations even back before industrialized society.
Oh yeah, 14,000 years ago.
Yeah, I mean, so is, in a sense, what we're talking about reflect an evolution of human nature, given that industrialization is, you know, not the only culprit of us destroying what we depend on in our environment.
Well, that's a really deep point.
I'd like to point out something here. And this is the First Nations people of North America have, in their cultures, traditions about not over hunting. You know, there's the old thing about we use every part of the bison. But that wasn't always the case. That the Clovid people, as distinct from the COVID people, which is us, but the Clovid people, these are the guys with the
spears that are that long.
with the shaped flint and obsidian points that were this long.
Right.
You know, 8-10-inch long spear points that were used for bringing down mammoths. And what they did a lot of times was they ran them over cliffs. Well, if you run a whole herd of mammoth over a cliff, I mean,
what are you going to do with all that meat?
You're not going to eat all that mammoth, right? So they killed way more mammals than they needed, and they did not eat every part of them. And as a consequence, a lot of critters went extinct. And people of North America also learned, oops, can't do that. With the ones that are left, which are a little harder to catch, like the bison who migrate, which is, you know, makes it tricky. You've got to be a lot more careful with what you've got. And so that then became part of the cultures of the people who live on this continent. But they learned this by making a big mistake that, fortunately, North America was big enough it didn't kill them off. The people who make this mistake on islands wipe themselves out.
Yeah, and I think people point to Native American beliefs sometimes about, you know, using all parts or saying a blessing to the deer or something like that. This was a way of teaching their children, you know, don't do that.
Don't do what the Clovid people did.
So Clovis people. Yeah. So we need to be able to teach our children what the limits are. Don't do this. And we have to teach them in a way that they'll listen. Because, you know, as an educator, kids don't listen. So how do you do that?
Yeah. So one of one of the analogies that we've actually used before in our podcast is something that I've heard in an environmental documentary, you know, many years ago, which is that if you have a frog jump into boiling water, it's just going to jump right out. But if it's in the water and it slowly boils, it'll just stay there because of the gradual change, and it'll just stay there and boil.
You know, Daren, I'm a zoologist, but I've never tried that.
It might not be true. It might just be a thing that people say.
I don't know anybody who's actually ever tried this. It's a good. I wonder if this is really true, but let's suppose it is. Keep going.
Yeah, I think I got it from Inconvenient Truth from Al Gore's documentary. But what I think that your presentation does very, very well is gives us a sense of perspective, because one of the kind of climate change denier rhetoric that we hear a lot is, well, we've had cycles, we go through ice age, and we go through the cycles, which we know, but this really shows us this is how rapid this is.
Yeah.
This is so incredibly rapid, and that's the problem. Our problem is not having the ability to see the consequences of our actions in our lifetime, because even though we're living now to 80 years instead of 40 years, even then this stuff happens over longer periods of time.
Well,
Back to on education,
actually,
how do we really let this sink in?
yeah, well, I think we are seeing it, and I think we're seeing it year by year by year. And I really don't, I mean, every time an environmentalist talks about grandchildren, I like cringe, because it's not about our grandchildren. It's not even about our children. It's about us.
Right.
And that we are seeing it, and that, I can't imagine the world that our grandchildren are gonna live in. But I think that this issue needs to be made much more immediate. That it's, what can we do today?
Right.
And and the effects. Okay, the other point as a part of that is that I think they call them like the co-benefits or something. That living, every step we take towards sustainability is healthier for us. Getting rid of fossil fuel would save millions of lives that are lost to pollution, to environmental degradation, to cancer, to every imaginable thing. So living without fossil fuel it's healthier. Living, and living in a sort of greener, more productive world is great. It's a good way to live. And so I think that, people say smoking, it'll cause cancer. Yeah, smoking causes cancer. And kids just say, let me live fast, die young, but
they say that when they're kids, not when they're
right, not when they're old. But the point is, what if you say smoking gives you bad breath? Yeah, smoking gives you bad breath. Ooh, I don't want. I'll quit because I don't want to have bad breath, not because I think I'm going to die of cancer in 30 years.
You're saying it may be more effective to change behavior, to focus on co-benefits that are immediate versus long-term benefits. Is that what you're saying?
Yes. Yeah. Yes. And I think those co-benefits are real. And, we've experienced it here in the changes that we've made in our house. It's a lot less toxic, and it's a lot nicer. It's just it's.
And this recording is coming to you courtesy of the sun. It's all solar powered.
Right. Yep. Same for here. So I'm going to jump a little bit in a political direction right now. We have a comment on Facebook, and this is from Gregory Nyberg, and he says, "Wind turbine tech here with GE. I was shocked to meet technicians that are on the fence and or don't believe in climate change, or the climate change is human related." And I read that, and that resonated with me. The first solar project I ever built in my life wasn't as Daren Golden with Golden Solar. It was as Daren working for a large general contractor building a utility scale solar farm in North Carolina. And most of the folks that I was out there with had this attitude of, it's just a contract. That's what we're building because we have a contract, but didn't really connect the dots with the ideals and the principles and the values of what it meant to be building a solar farm. And it makes me take a step back and just wonder, how can we really educate the next generation that this is real, that we really have to do this?
Well,
we need all hands on deck.
Sure. Yeah. Gray's book is a part of that. One of the things that I've seen, and Catherine Hayhoe also comments on this, is that people don't really get climate change until they experience it. And that's what does the conversion. When the farmers say, oh my God, this drought is just like going on longer than I ever expected it could. Or, this is the third time our house is flooded or our city is flooded. What the heck is going on here? that's the stuff that makes people believe. Or if the tornado comes through twice in 2 years, that's the stuff that changes people's minds. Gray is hoping that by being able to look back in time, that people will be able to see, oh yeah, this is part of a bigger pattern of how the planet functions, that these things are connected. It's because one of the sort of denial aspects is, yeah, it's hot, but I'm not convinced.
It's been hot before.
I'm not convinced that this is because of extra carbon dioxide. Or someone says, yeah, the climate is always changing, which in fact it is. But
our friend Marco Rubio.
Yeah, but how does it change? And how are these things connected? And it's in these graphs that you start to see that so well.
And I think one of the powerful things is, as you move back in the graphs, like the first few, you say, okay, well, it's going up, okay. And then you see it in a larger, that really is going up. And you see it in a large, that's like way out of line.
Off the charts.
Mm-hmm.
Yeah, off the charts. And if you see any of those charts sort of without the others, that you don't quite get it.
Mm-hmm.
Are there any examples?
That's why Gray made the book.
Yeah.
Are there any examples where carbon dioxide has been where it is today, where conditions were also livable in a time period? Looking at it as being a cycle, are there cycles where there was a livable temperature with the current concentration of CO2?
Go back to that figure.
Yeah, if we go back to the 100,000 years. Where is it? Is it this one? No, it's this one. There are scientists out there who doing more research on this time period, and those dotted lines that you see here.
Can you screen share there?
Oh, I'm sorry. I thought I was still.
New share.
New share.
Desktop.
Okay. Oh, I see what. Okay, can you see it?
Yep.
Okay. That these dotted lines, this is a model. These are not sort of direct measures. This is a model that has been deduced from other information. And there's
back up a second. To be clear, it's not that it's a model. These are calculated data.
Oh yeah, they're calculated data. It's just they're not direct.
So how do you? Well, none of these are direct, because in no case except for the last maybe 100 years have we been around to record the temperatures, right?
Well, right.
So
they use proxy.
So you've got, in every single instance, you've got to figure out what the temperature was based on something that you can measure.
Right.
So what were they measuring in the dotted lines here? How did they come up with those temperatures?
Okay, the temperatures here, this orange line, those are made from foraminifera, which are tiny little creatures that are found in lake and ocean sediments, and they contain an oxygen isotope, and the difference between oxygen 16 and oxygen 18 gives you a proxy for the temperature. There is no direct proxy for the CO2, although there's been work in that direction, and there have been some measures that they've been able to do. So it's just that there's more research that is being done.
You missed a step here. So the point is that they're calculating CO2
right
from the inferred temperature based on the ratio of oxygen isotopes in these little small organisms that are preserved in the lake sediments. And so that's kind of what they've had to do. In some cases, in this part, for instance, they can actually go back and drill into the ice and take out ice cores, and the ice cores are full of little tiny bubbles. And they can capture those bubbles and analyze the CO2. They go farther back in time, and they've got to calculate the CO2 concentrations based on other biogeochemical processes that they can measure.
Right. But this was the last time that we had carbon dioxide concentrations that we have today. So it's really interesting. What was life like? What were the temperatures? What was the sea level?
Mm-hmm.
And temperatures, well, yeah,
They were a little warmer,
a little warmer.
but essentially it was livable.
Yeah, it was livable.
So that is to say, at the temperatures that we have today, we can live. I've also corroborated that independently, being alive.
Right.
Now, the problem is, what if we go above this? So Gray, take us up above this and see what happens to our temperatures. Oh man,
You know, ka-ching.
that's when we start getting into problems. The data get a little bit vague back then, but the temperature data are a lot more reliable. And we're getting up into temperatures where a lot of the planet,
we really can't live.
a lot of the planet becomes unlivable.
Yeah. The other interesting thing, one of the reasons I'm interested in the Eemian period, which was the last interglacial, just before the most recent ice age, when temperatures were a little bit warmer. I mean, we're pretty much in Eemian temperatures at this point. CO2 was a little bit higher than, it was around 300 and a little bit. So the CO2 was a lot lower than it is now. Temperatures were higher, but sea level, that's the one to keep your eye on. Sea level was up like 10 meters.
Ooh, 10 meters. That's like a
20 meters.
that's like a 3 to 5 story building.
Right.
Yeah.
Okay, so the planet is fundamentally livable, but the coastal regions are gone.
Yeah,
They're way inland now. So so the planet could survive, but forget the coastal cities.
And the other dimension of that, right, is the how quickly the change happens, because is life livable, but there's also, is society like able to continue, without like all the things that happen in society when stuff is difficult, like war, political unrest. Like this is multifactorial, right?
Yeah, this is really worrisome. And already there are climate refugees, and this is what I mean about, it's not our grandchildren, it's us, it's now.
But the climate refugees we have right now are from the drought areas, and the other ones we're going to get, which we don't have now, are the coastal refugees.
The sea level rise.
That includes us.
Yep.
By the way,
right.
People who live where we live are going to be the coastal refugees.
Right.
What about Phil? It seems like I remember talking with you about insects.
Folks going to read us with open.
Sorry, I might have some delay here.
All right. That's all right.
We talked about insects one time, about how they would be affected by a quick change in temperature, that there was the speed of change related to how like some populations of life would thrive and suffer.
Yeah.
We've already had a big crash in insect population.
We've lost a large fraction of the world's insects.
Mm-hmm.
And the reason is not typically that insects have a very narrow temperature range. They don't. But the bacteria that live inside them, the obligate symbionts inside them, are probably affected by viruses which thrive when it gets a little warmer. So it kills off the obligate symbionts, and then the insect's in trouble and dies. So just that little change in temperature upsets that whole delicate balance between the viruses and the bacteria and the insects that they've already negotiated, and everything changes and the insects perish. That's our best guess right now as to why we're losing the insects.
And insects are the absolute foundation of the food chain.
Yeah.
Mm-hmm.
So this is not cool.
So I think that the elephant in the room is population growth, right? If I got the numbers correct, it's
yes,
2 billion a century ago to basically 8 billion present day.
Well, right. Now you have to be real careful here, because who's going to step forward, right? But the other part of it is that,
how does that population live?
Yeah,
because
that's probably a bigger factor.
You have to recognize that developed countries, which represent a relatively small fraction of that huge population, we're releasing and have released most of the carbon. So one of the time bombs, of course, is what happens when there's a couple time bombs in there. What happens when the developing nations decide that they deserve and are able to acquire the same standard of living that we have.
Mm-hmm.
Can that be
Fossil
done?
fuels.
Can that be done in a low carbon fashion? And the second one is when people start moving, you get global warfare, and nobody, whether you're rich or poor, is going to stay still when your home is being destroyed by climate-related factors.
Yeah, sure.
So.
Yeah.
So the nature of every animal and humans not being an exception to do
Right.
whatever they have to do to survive. And
Right.
so I wonder, even if we had half the population, even if we were 4 billion, but, had the same sort of carbon footprint per person, we're still so far
Exactly.
ahead of where we were a century ago.
Yeah. Yeah. Exactly.
So I kind of envision that maybe there will be a lot more maybe philosophy and folks that specialize in ethics discussions to kind of talk about that interface between
Yeah.
population and our long-term ability to survive on planet Earth.
Well, there's a couple of them. I'll say three sort of important pieces here. The first one is that carbon pricing is probably the most efficient way to get a control on our carbon emissions.
Mm-hmm.
It's about 100 times more efficient than the CAFE standards in terms of how much money you spend for how much carbon you save.
Mm-hmm.
And so, carbon tax, carbon dividend kind of system is probably the biggest and most important systemic way we can bring carbon under control. Second one is education. Education raises the standard of living, but also educated women have fewer kids.
Mm-hmm.
And and when you're pretty guaranteed that your children are going to survive, you don't need to have so many.
Yeah.
And the third one, this comes from Drawdown.
Yeah. You know that book.
Is they've figured out that efforts to educate women are one of the very best things we can do on the planet for bringing down carbon pollution. So it's this combination of a carbon dividend system and educating women, educating girls. If you do those two things, you'll conquer a lot of the problem. And it seems really doable, doesn't it?
Sure.
I mean,
sure.
there's a law we need and some decent education. Can't we do that?
We
In
should.
the information age.
I mean,
Yeah.
that's the basis for not being in despair.
Right.
Is that the solutions we have to save the planet are so easy to attain, easy technically to attain. We have the technology to do this. We can tax carbon. We know how to make alternate energy, capture, and we know how to educate girls. I mean, these are things we all know how to do already. It's not like we're not waiting for some new carbon capture device or some next generation nuclear thing to get made.
Right.
We can use the technologies we have today. Keep working on the batteries, please.
That's what I was going to say, yeah.
The technologies we have today, plus some better batteries and global education, that's within our reach.
Yeah.
And I think that an important point is that every step we make toward those goals makes our life better. Every step we make toward clean energy, every step we make toward educating women and lifting up people who are in poverty, every step towards social justice makes our lives better.
Yeah.
And that's the sort of virtuous cycle that, and that goes with a sort of shift in thinking as well. There's actually been quite a lot in social justice about, the right to migrate and about the rights of, people.
Yeah, that reminds me of like a famous, cartoon caricature that you see in newspapers where they're saying, well, what if climate change isn't real? Well, then we will have cleaned up our air and cleaned up our water and
Exactly.
done all of these other things and figured out how to be self-sufficient and energy independent for nothing. Okay.
Yeah, how bad is that?
Wonderful things to have done.
Right. So I think that's an important point that, that it helps us at every level.
Yeah.
I want to bring up
also the education. How do we educate our children with a set of values? And this is the question about Native Americans. How did the Native Americans educate their children not to overfish. Although every kid in the world wants to overfish, you know, and
Yeah.
you know, and
Something.
kids don't do what the grown-ups say.
So something that we hear a lot of these days is the double-edged sword of the internet and the abundance of information. That almost every voice sounds like a legitimate voice, even if it isn't, right? You've got radio show announcers kind of just saying whatever they feel
Hey,
like saying, and
whatever.
they've got their cult followers just taking what they say as
Right.
absolute truth.
And we have our president.
Right. I mean, is there some kind of responsibility that maybe Facebook and Google has to take onto themselves to say that if something's downright scientifically wrong, it's fundamentally wrong to spread misinformation for political gain and
I think
financial
so.
purposes of corporations.
Yes, I think so. I mean, when you talk about a platform, you know, that they say, oh, well, we just provide the platform and we don't police what people do with the platform. Okay, well,
I just make the bullets. So, what you do with them.
right, that's up to you, you know. I just make the highways, you know, what you do with it. It's like every time we have made a platform, like newspapers as a platform or infrastructure as a platform, that there has been policing in place.
I don't burn the oil. I just pump it out of the ground.
Yeah, right. So I think this corporate profit without corporate responsibility is a problem.
Oh, and here's something fun to watch. The oil companies are now coming into an idea where, hey, they can say we can make our extraction and refinery processes run on renewable energy, so we can now claim we're a green industry.
Yeah, come on, you know.
And that's what the Saudis are doing. The Saudis are going all in for renewable energy. Like, why burn this stuff when we can sell it? Because we can actually run our countries much better on solar energy than anything else. We got tons of sunlight here.
Yeah, and let's sell the oil.
And sell the oil. So this, the Saudis are converting their economy over to a green economy while destroying the rest of the planet. But there is a divine justice here, and that is that much of the Middle East will be unlivable as the CO2 levels rise. So they are destroying their world.
Yeah, I've got a little map to that effect, that there are areas in around the Persian Gulf and also in India, sort of along the Ganges. Is it the Ganges? Anyway, it's right at the base of the Himalayas, that they're getting temperatures now that are occasionally that are above, I think it's 35 degrees Celsius wet bulb. And above that, your body simply cannot shed enough heat to survive. Right. You cannot survive in those temperatures.
And that comes back to the idea that people did not evolve for that kind of climate.
Right. And so that's that those areas, and particularly in India, there are 1 billion people that live there. Like what?
Yeah. And I want to correct an error that I made earlier. I said that back when the pterosaurs and so forth were out, it was a lot bigger temperature swings. In fact, that's exactly the opposite of true. The temperature was much more stable.
But it was high.
And mammals are actually adapted for big temperature swings, just can't be too warm. We can handle cold, we mammals can. And that's one of the problems the dinosaurs had when the KT, when the Chicxulub meteor hit, was that it cooled things off and they couldn't handle the low temperatures. But we do have an upper threshold. We evolved for.
We're an ice age creature.
We're an ice age creature.
And my gag about that is that's why we can live in Chicago, right?
Yeah. Right. But we evolved for forests where it's kind of cool to sort of warm, but not incredibly hot. And other than that, we really depend on shade and the ability to cool our bodies.
It makes sense, because if you're really cold, you can put on a fur coat, you can put on things. But if you're really hot, there's only so much you can shed.
Yeah, exactly.
Yeah.
So there's a couple of questions here. We have one from Facebook, and we have one from Elliot, who's helping us set up the stream here. But it kind of ties in. I think it's a good example of just what happened. You made a correction there, Phil. And here I am in my hometown, And I find myself a lot less surrounded by, well, especially during quarantine, but ordinarily when I visit my hometown, there's a lot less camaraderie around these ideas when I visit the people that I grew up with than when I'm in Miami around people that are working in climate. And so most often I get challenged about, these sorts of ideas, and a lot of the things that get brought up are exactly what I think your book addresses, Gray. But there's this almost like kind of wishful thinking. I think Greta Thunberg said it, that if you don't like the facts, that doesn't mean that you can just make up your own.
Right.
But at the same time, there are examples of where science has revised its original statement, and that science pivots, and that there are things that change.
Sure.
How, like, do we as a society have a responsibility to follow the current evaluation of the scientific community?
I think it's the best we've got.
Yeah.
We're just people. We're just doing our best, and if we don't do our best, it's on us. And the science is the best we've got.
One of the questions I had for Gray was, as the data sets get better, how do you think this story is going to change? And she told me the answer, and that is that it's going to change in a couple of places. One is, going forward, we'll have a better sense of our trajectory, and the other is, going backwards, we'll start filling in some of those synthetic data with better measured data.
Yeah.
And so sort of in the deep past, we'll have a more clear picture of what happened, and we'll have a tighter set of predictions on the future. Obviously, we know right now what's happening pretty well, and so it gets blurry going forward, and it gets blurry going backwards. But if you think about how one of the places where we apply science the best is medicine, and in United States, we have evidence-based medicine, and we always go from the evidence we have today. And COVID is a really good example of this. We got a virus we'd never seen before, and we were just trying to figure out how it works, how it's transmitted, et cetera. And so we started out by going to a different SARS virus, the previous SARS virus, and using that information to our understanding. And as the data came in on this SARS virus, we changed.
We're changing.
We changed the projection.
About it.
We learned how it's transmitted. It's transmitted a little differently. It manifests in the body a bit differently. And we keep adjusting. We keep changing our practices according to the knowledge we have today. What's the cost of not doing that? Everybody dies. So you can see, if people have said, well, we don't know everything there is to know about this virus, so let's not do anything right now. A lot more people would have died. And as it is, a huge number of lives have already been saved. Hong Kong is the most amazing story on the planet, because they have the highest density of anywhere on the planet
by far.
And they stopped COVID in its tracks almost immediately by using the best science.
Amazing.
And they didn't know everything that we know about it today, but they knew enough, and they applied it based on the lessons that they'd already learned. And the best success story on the planet is using the imperfect data you have today to make the best decisions you can.
Yeah.
So on the subject of data and acting on data and information and misinformation, we kind of see the moving of the goalpost of the consensus on climate change. A couple of years back, it was, is it happening? I think nowadays everybody agrees that it's happening, but the new debate is it caused by humans or not, or to what extent? How far into the future do you think we are until it's just a given that we've done this and we're doing this, and we have to all hands on deck reverse or change course?
Well, anybody who's paying attention has come to that conclusion some time ago. So it's just the yahoos out there who are not they're
people who are choosing to ignore the evidence until basically their own house gets clobbered. So folks in California who denied climate sort of took it a little more seriously after the wildfires. Same thing in Australia. People get serious when they have to, and they start looking for the best explanations out there.
If
Yeah.
your house is burning, do you sort of look at it and say, oh well, that's not as hot as it might have been, or it's only the bedroom that's burning, and
Yeah,
I'm not sure that water will put it out. Here, let me try gasoline.
right.
It's just like, if you're not using the information that is available to you, then like, what are you doing?
I mean, I'll tell you about my own life as initially as a climate skeptic. And I say this because I'm old enough that I used to lie awake at night worrying about the next ice age, because I really don't like it super cold all the time. I'm sort of a skinny guy, and I get cold if it's really cold out. So I mean, I can be active and so forth, but I always thought ice ages would be terrible to live through. That was my biggest worry. We'll get something like the little ice age will come back in my lifetime, and I'll be cold all the time. And so I'd lie awake at night worrying about the return of the glaciers. And when in my early 20s, Jim Hansen made his discovery, and I was a graduate student, and I had access to the journals Nature and Science in the common area, and I'd sit and read them during lunch. And I began following climate science back in the early 1980s. And so then I began wondering, oh, is this real? Is this really happening? And we didn't know, because people were just starting to look for it. And the studies started coming in one by one by one. And so I went from I wonder if this is real to this is not looking good, I hope it's not real, to oh dear, this is looking like it's probably real, to finally, oh my God, this really is real.
Yeah.
It was that whole set of steps that I went through in the 1980s, watching the data come in. By the time we got to the 1990s, I was already on board, because I had watched this for a decade. I'd watched the scientific revolution unfolding for a decade, and I knew what I was looking at.
Right.
Yeah.
Anyway, just to say, but for people who are coming to this afresh, they kind of have to go through the same process.
Whole process.
It's like, how do you take something as outrageous as these claims and come to have some faith in them? And it takes looking at
12 steps of grief, if you will.
Yeah, something like that.
You got to look at a lot of information, and you have to come to terms with it.
And
we have a question.
Yeah.
Go ahead.
Well, what I'm hoping is that this book, in just laying out the data, just maps, graphs. First of all, it's visual, so that you can see it, and just laying out the graphs one after another, after another, after another. What I'm hoping is that it will help people who are, don't know very much about it but are interested, and that it will help them get a handle on some of the information that they're hearing, and give them an armature in which to put it.
Yeah.
So that somebody says, oh well, 100,000 years ago or 100 million years ago, this happened, that happened. Okay, well, like, what was that? And so I'm hoping that will help.
I wanted to, we had a comment about grand solar minimum, and I've heard this, a half a dozen times through being at presentations, and people will put forward that we're at a grand solar minimum, and
okay,
a decrease in the sun's energy. Like, are there other things that are laid over the graphs that you have that can affect them? Like, can you address some of those kind of potential escape routes for us, deciding that this is as bad as it's?
Okay, let me show you. Okay, here's one of the. All right, hang on. Okay, I have to get back. Okay, I'm going to share my screen again. I'll show you one of the graphs that I didn't show. Share screen. Okay, can you see that?
Yes.
Okay, this is the variations in the orbit of the sun that in the past drove the ice ages. And so, yes, there are variations in the amount of solar energy that we get And what's really critical is when during the year do we get that? What is the season at which the sun is either closer or farther? And essentially, what face does the Earth present to the sun at various times of year? And so there are three ways that it varies. One is in the elongation of the ellipse as the Earth goes around the sun. One is, so that is, this one, that it goes from being more round to being more circular. The other one is the rotation of the ellipse itself. So the ellipse goes from this way, it goes to this way, it goes to this way.
Precession.
Yeah, the precession of the ellipse around the sun. And the third one is the tilt of the Earth, that it's either more vertical or less vertical. And the amount of land in the northern hemisphere, because there's so much land in the northern hemisphere, the amount of ice that can accumulate in the northern hemisphere is affected by these pretty subtle changes in the amount of sunlight that we get either in winter or in summer. So yes, this is I'm not entirely sure exactly where we are. Yes, maybe we are at a point of maximum insolation or something like that. But that's a minor thing that that drives much cycles of the ocean currents and so forth that will send us either warmer or colder. In other words, these changes themselves are pretty subtle, but the effect that they have on the amount of ice in the northern hemisphere then drives the ocean currents such that heat is distributed differently throughout the planet that can take us into an ice age or draw us out of it.
I have a different way of viewing this. Can you go to the 100? No, can you go to the 100 million year graph or the 10 million year graph?
Okay.
Take me to 10 million.
Up, take you to 10.
And then we're going to go back to 100.
10
Yeah.
million.
10 million. Okay.
Okay, can you see that?
Yeah, no, I want the 10 million.
Even before that?
Yeah.
This one?
Yeah, okay. So one of the things you can see here is there's,
Okay, can you all see the 10 million graph or not?
Yes. Yep.
okay.
You can
So
see that?
so in the 10 million year graph, one of the things you see over on the far right hand edge is you see the CO2 is bouncing around here. You see this bounciness here in the sea level. It's pretty broad. This is the ice age period. Okay.
Right.
That much there. That's the ice age period. This is the ice age period here. The last 1 million years roughly is the big ice age period. Look at the CO2. It's way outside of that range. So what you're seeing in this period here, that's the precession effect. That's the minimum to maximum insolation effect. So the sun's wobble, the sun doesn't wobble, it stays still. The Earth's wobble, the Earth's changes in orbit, that takes us across this range here. And now our CO2 levels have basically broken the ice age cycle. We are way out of the ice age cycle. With this much CO2, we cannot get back into the ice age cycle until we manage to get that CO2 level back down again. And that's going to take us a minimum of 100,000 years. So we broke it. You know, it's like the Pottery Barn thing. You break it, you own it.
Right.
We have broken the ice ages.
Yeah, we've canceled the next ice age.
We've broken that. We've broken the significance of that whole precession, tilt, wobble, etc.
But that whole precession, tilt, wobble, and so forth was going on back here too.
It's always been going on.
It's always been going.
It's just a question of what
going on. It's a question of how it tips off, sort of
what it drives.
Yeah, what it drives, the ice and the ocean currents.
And we never saw it dominate the Earth's climate until about 1 million years ago.
Well,
you can
3
see
million.
You can see it's starting to happen at 3 million years ago. That's when the Earth makes a transition into this phase. and then it develops across the next 3 million years
Right.
into a very regular pattern of oscillations, where that tilt precession is really dominating the climate, the global climate change. And now we busted out of that.
Yep.
So that's a really
That's a big deal.
that's I think the biggest surprise for me from Gray's figures was that we have broken out of the ice age system.
So if I've understood it correctly, our effect on the planet with our industrialized way of life is so profound that it supersedes any of the effects of
Yeah.
the tilt and ellipse of the planet.
Not only does it supersede it, it has basically disconnected that from driving the climate like it has for the past 3 million years.
So I can understand. I think it's more obvious for me if I'm taking that role for that person that's viewing or was viewing, that's concerned that this could be a driver for the change of solar cycles. It's easy for me to understand the relationship between the sun and temperature, because that seems intuitive.
Direct.
And it's a little. It's less obvious. You showed it in terms of carbon dioxide, how we're off the chart from where that wobble could have been attributed to the sun. It looks like temperature is less obvious, but can you clear up how the sun relates to carbon dioxide?
Okay.
Yeah.
Yeah. Okay. So the best greenhouse gas we have on the planet is water vapor. So it's actually way more effective than CO2 because we have so much more of it. We have very little CO2 in the atmosphere. We're talking 400 parts per million. That's a small amount of CO2. So you might say, how does CO2 even matter? Well, when you get up to the poles, it's colder up there, particularly in the atmosphere, and there's very little water vapor up there. So now CO2 is the dominant greenhouse gas and makes all the difference in the world. So if you've been watching the weather, the weather channel or whatever, one of the things they'll tell you is, oh my God, we have this incredible hot spell in the Arctic right now. It's like 50 degrees Fahrenheit in the Arctic.
Wow.
Like what the heck is going on here? And this is in the wintertime. They'll get these warm spells in the Arctic. It's just insane. Well, this is because there being so little water vapor, the CO2 can really alter the Arctic atmosphere. And those changes is what's destabilizing the planet. It's not what's happening here in the tropics or even in the subtropics or the temperate zone. The big drivers to our climate are happening in the poles.
Yeah,
And that's good old fashioned the greenhouse effect, right? Because the light is going in, bouncing off
the dry air. And when if you've ever been up north, the air holds a lot less moisture. That's why you get frost inside your freezer. It holds a lot less moisture. That means CO2 is super important in the Arctic and the Antarctic. And unfortunately, that's where we got all the ice.
Yeah.
So you're saying that in the instance of the sun, like here looking at the ice age period, like let's look at I guess 1 million years ago.
Yeah, go back 1 million.
You've got the so if we just highlight that part, then you would say that this fluctuation here is attributable to our relationship to the sun. Is that
Correct.
Just one of the factors, or do you see that as
that's it? That's it.
Okay.
No, hang on. You have to say yes. It moves with the variations in the sun. That the variations in this insolation is like a catalyst that sets off a whole other cascade of effects.
Yeah.
And what we're saying is now with the CO2 as high as it is, that we've moved that those effects are no longer in play. They're that yes, we have variations in the insulation, but it's not going to bring it down like it did in the past because we've melted the ice essentially.
So if I'm that person that commented, why can it not be that the temperature is cyclical? Because the temperature doesn't look, obviously distinct from previous cycles because of the sun. How can you say
temperature lags CO2?
Okay.
Because remember, you've got all this ice acting as a buffer, right? On the climate. So you still got a lot of ice in Greenland. You still got a lot of ice in Antarctica. It's melting, but it has not yet all melted out. When it melts out, you've got a very different planet. Because now you've got no more albedo at the poles.
Right, and the ocean currents stop.
The ocean currents stop. And so what the Gulf Stream does, which is part of the Atlantic meridional overturning circulation, is it acts as a pump that moves heat from the tropics up to the poles where it cools off again and comes back to the tropics. So it's a great big air conditioning system for the planet. That breaks. And no longer do you reflect a lot of sunlight because Greenland is no longer white. It's the color of rock. And the Antarctic is no longer white. It's the color of rock. So now you can absorb a lot more heat. And you've got a different planet than you do today.
Yeah, we're back really to this kind of condition.
So you can't say that the temperature is a natural cycle and the CO2 is not driving, temperature.
It was a natural cycle.
But we've busted out of it.
For the past 3 million years, it's been a natural cycle, and we've broken that natural cycle.
Right. But you can't separate the two. Like the rise in carbon will precipitate a rise in temperature, but like you said, it's just a lag. Understanding the relationship that our average global temperature has to the condition of the poles, where carbon dioxide plays a much bigger role, connects those two. Like that there's a causal relationship between carbon dioxide and temperature, meaning that you can't attribute the temperature to natural causes and say that the CO2 is irrelevant. We're just not seeing
It's simply not true.
Got it.
The other lagging thing is sea level rise, or sea level. Like in the Eemian period, that we had temperatures roughly what they are now. We had CO2 that was around 300, much lower than it is now, but the sea level then was up, 10, 20 meters. So, when they talk about sea level rise, it's not like it's going to stop at 6 feet. It's just getting started. And they say it's baked in. Yeah, it's baked in at this point.
We're going to get sea level rise, but we don't have to lose the whole planet.
Yeah.
Right.
The planet can be saved.
Well, the planet.
Well, I guess the planet will be here.
The planet will be here.
We won't.
We may not.
Yeah.
And it's just the damage that we're doing now.
Yeah.
Will last a long, long time.
So on the subject,
the question is, can we bring ourselves back into some kind of equilibrium?
Yeah.
Different.
On the subject of sea level rise and the fact that the whole planet's not going to be underwater, there still will be some places that are habitable on the planet. Phil, you brought up a very interesting subject a couple of months ago when we got together, which was an idea of a demolition bond, where anybody that still wants to do something as crazy as develop near the ocean in present day can, but they should put some money down to make sure that when that terrible idea inevitably doesn't work out, that there's some money to cover the cost of basically returning that area to Mother Nature. Is that something we can chat about a little bit?
Yeah, so I'm changing the name of it from demolition bonds to restoration bonds.
Okay.
And I think it's a more positive sounding name. And there's I've also discovered, of course, there's the whole surety bond market. So there's actually a process for doing this. But the general idea is that if I'm a developer and I want to build something on Surfside or Miami Beach, everybody sort of goes, ooh, gee, that building, someone's going to have to take that thing down at some point when the water gets it. And I may say, yeah, but I can make money for 30 years on it. It's worth it to me for 30 years to do this. And you may say, yeah, but I don't want to get stuck with a tab for taking down your nice building, Phil, when it ceases to be a nice building. So how do we reconcile this? Do we put a moratorium on development? Or do you just say, okay, you can build your building, but you got to pick up your toys when you're done, And we're going to find a mechanism to hold you responsible for making this into a nice seashore again.
Mhm.
You know, for taking your building down and putting away all the pieces. And I
Mhm.
think, you know, I favor that approach. If you want to sort of, you know, stick with
Yeah.
market solutions as long as you can, let's require people to, you know, put down a bond that says, even if I go bankrupt, there will be money set aside to restore my property to the standards that are required for to give it back to the ocean. And in exchange for that, I get the right to keep on developing. And maybe I'll, you know, and there has to be somebody who's willing to underwrite that bond. Either I put down the cash up front in an account, or somebody with deeper and more widely distributed pockets is responsible for picking up the tab if I go bankrupt.
Yeah, and this is part of the whole sort of whole idea about being responsible for your actions, sort of corporate responsibility, right? If you make a plastic bottle, then you need to be responsible for where it goes in the
Right.
end. And
Yeah, and that really kind of resonates with me because we're completely familiar with the idea of an interface between an ocean and a land. We call that prime real estate. But you know, the consequence of that ocean creeping up to the land is maybe some of these buildings that we built aren't really fit to be digested by the ocean. One of the things that has happened in Michigan that I read on the internet, Dow Chemicals has admitted that you know, after that dam has failed, a lot of the water is now mixing in with chemical holdings
right.
areas, and now a lot of chemicals are now in the water. So it really makes sense that, you know, we have mechanisms to have development cleanly and safely be restored as the ocean creeps up.
Yep,
Yeah. Yeah.
that's well put.
Well, I think that I feel very privileged to have access to this level of analysis on what's happening. I mean, I feel like probably in the top percent of who gets to already have rich conversations about it like this. And this is, you know, beyond what I have even gotten to see as a perspective. So, you know, me 2 years ago, or someone who's not part of this space who gets to see, you know, this level of detail that you've put all these data sources together and compiled, I think is much appreciated work and a great privilege for all of us. So thank you for doing it, and thank you for coming on to share it with us as well.
Well, thank you.
Thanks, guys.
Yeah,
Thank
thank
you
you.
very
This is great discussion.
Great. All right.
And Greg, I have a question for you. Is, you know, you mentioned the book. Is there a website, or is there somewhere that we can find that book, or that our viewers can find the
climatex10.net.
And there's a shop
We
on
should
there where
put
people
that
can.
up on the screen. Climate. All right, I'm gonna. Yeah, let me go back. Ah, yes. If
Share your screen,
share your
and just go up to the website itself.
Okay. Well, actually, it's right.
Yeah, but call up the
No,
browser.
no. I'm gonna go right here. Okay, right there. You see that?
climate text 10.
Let's see, Gray. I'm on the website, and I'm wanting to know where to buy the book. Where
Well,
is it on here somewhere?
No, I mean the book as a book doesn't exist.
You have
Yeah.
to be very privileged to have Greg give you a copy.
Yeah,
So-
I've made some, but it's it exists as a website at this point.
Yeah, her number one fan and sidekick, me, has been goading her to get the darn thing published. I think it's really nice to have in your hand and be able to flip through the pages and get a sense of time with your thumb. You know, we were just sitting in bed with it last night, flipping through the pages and talking about some of these stories. So I'm glad you're with me in encouraging her to get the thing published.
Right, but
We'll sell it on our website if you do. Yeah, we love the idea.
okay, but you can see this image, the Climate X10.
Yeah.
Yes.
Okay,
Yep.
yeah, well, that's it. And yeah, you know, hopefully someday it will be a physical book.
And one of the things that's in the website, if you go there, or in the book, if you manage to get your hands on a copy, is she lists all of the scientific sources for every data point.
Everything is footnoted.
Yep.
Very cool.
Good.
You know, on all the graphs, they're there are links to the sources for every bit of data.
So you can look for yourself. You don't have to take our word for it.
Maybe we'll get the Netflix special published with
Right.
CGI graphics to recreate some of these images in
Right.
video
Right.
form. Very cool. Well, guys, I want to thank you so much for joining us. We started, our Fridays with Daren sessions for folks that were sheltering at home during COVID, and figured this is a great outlet to connect people that care about the planet or want to do some learning. And really, like Dane said, we're really privileged to have your insight and expertise. So I want to thank you very much for joining us today.
Yeah, well, thank you for inviting us.
Absolutely.
Right on.
Take care.
Thanks.